Hi guys, BuildZoid here, and today we're going to be looking at a 3700X with an oscilloscope. So we're going to be looking at the operating voltages. We're going to be looking at the power consumption. So that's this right here. So basically, I have a 3 milliohm shunt resistor being monitored by an INA 219 from Texas Instruments, and then that's being controlled by an Arduino since it has an I2C interface. So yeah, anyway, so we have the readout, we have a power readout from that. Then there's of course the oscilloscope, which is just hooked up to the back of the CPU socket. And the motherboard is a Gigabyte X370 Gaming K5, which is why I think we're currently idling really high. Like the idle voltage right now is this average 941 millivolts. That's actually really, really high. When I was at Gigabyte and we were testing messing around with the X570 motherboards, I did a test of like how does Ryzen behave at idle, and basically it should idle as low as like 0.3 volts. Not constantly, and I'm not sure actually, like as far as I know, the threshold voltage for 7 nanometer shouldn't be that low. So it was like 0.26 something. So Ryzen has something weird, like AMD has something really special going on with being able to run the CPU on like, well, it's not really 0.2 volts because you basically like it wakes up the CPU to like 0.9 volts and then it goes back down to 0.2. But anyway, I think the voltage regulator on this motherboard is just too awful to support that really like super low voltage idle. So right now we're just idling at 0.94 volts, but yeah, which isn't super low, but you know, it's low enough. So that's kind of unfortunate, but I didn't really feel like the thing is, this is a motherboard, the X370 Gaming K5, it used to live in my daily system, but at this point it doesn't live in my daily system anymore. So I don't really have a use for it. So I've basically started just tacking on like measuring capabilities. So like there's some other stuff I've done with this board for monitoring like memory power consumption and other stuff. And yeah, right now it's just like, now it's modified for doing these measurements with Ryzen. So anyway, we have a 500 millisecond timescale right now per division. So we're looking at like, I think 2 seconds, I don't know how many divisions there are, but a lot. Like we're looking at several seconds right now and a voltage across several seconds. So right now, as you can see, I'm not doing anything on the desktop. I'm not moving the mouse. I'm not even touching the damn mouse. And we're idling at 0.944 volts. If you had an X570 motherboard or just a better motherboard than this, it should idle even lower. But anyway, let's start moving the mouse. And okay, so still idling properly. This is with the latest AGESA, so that's the ABB version. So this is BIOS F42A for this motherboard. Anyway, so if we just move the mouse around, nothing really happens, so that's a good thing. But what if we start... Yeah. So the boost algorithm, in its infinite wisdom, understands that, you know, dragging around on the desktop means that we're doing stuff, and like that's more instructions than just moving the mouse around, and so the algorithm just freaks out and decides to try squeeze as much of the CPU's TDP into a single core, which leads to an average voltage of about 1.46 volts, which is actually, like for low loads, that's actually in spec for AMD Ryzen 3rd gen, so that's normal. Also, you should just ignore the max voltage, okay? Just ignore that, because that's like including voltage regulator overshoot, and also the way I'm probing right now is like less than ideal, so it's going to be inaccurate. For like max voltage you can ignore, minimum voltage you should also just ignore. Just watch the average voltage. That's really all we care about. Like right now I'm trying to use the scope as basically just a glorified multimeter, so well, ultimately that's what a scope always is, but like just ignore them, okay? Just take my word for it. Ignore the max voltage, ignore the minimum voltage, because they're just measurement side effects. And we're also measuring from the back of the CPU socket, not from the actual CPU. So anyway, let's go back to Windows, because I can't actually see what's going on. And we're going to go to the control panel, and this Windows install is all kinds of messed up. So I don't have like the chipset drivers installed or anything, because like it'll explode or something. Like I'm worried this install will like blow up if I try to do anything to it. But anyway, we're just on regular balance, and I think this is Windows 1903, I think. I'm not 100% certain. But it might not be. That actually might explain why the idle voltage is so high. Or, though I still think it might be a motherboard thing. But anyway, so yeah, we're on balanced power plan, and yeah, so If we leave it alone, if we idle, if we do true idle, which true idle is nothing running, because the CPU understands anything running as not idle. So you can see that, you know, true idle, we're doing like 0.94 volts. So that's great. What if we open up like hardware info? What does that do to our idle voltage? Well, let's just run that. And this, apparently hardware info got a recent update, but I haven't bothered to download it. And we'll let it settle, because obviously we can see that the voltage went up just to start the application, because that's work, right? And yeah, and now you can see these periodic spikes, and those are basically hardware info polling the entire system, actually, because if we go to my settings in hardware info, so there, if we go to the settings, well, no, also I wanted to go to the temperature readout, but there's the temperature readout. There's the temperature readout, yeah. So that's that. But if we go to settings, you can see that the polling rate is 2000 milliseconds, which roughly corresponds with the gap between those spikes. I think. Like, you'd actually have to count it. I can't be bothered, so. But it should be 2000 milliseconds between them. Or roughly 2000. The thing is also like the way the trigger's set up, so anyway. So yeah, you can see that basically anytime hardware info starts doing its polling, it brings the CPU out of idle, because it basically asks the CPU to do work, which the boost algorithm interprets as, hey, I gotta do freaking work. So it just boosts as hard as it possibly can, because it's basically racing to get back into idle, right? So anyway, let's go and put this back here. Let's start running some stuff. Let's say, I don't know, Cinebench R15. Gonna open that up. And yeah, this Windows install is all kinds of broken, so we're just gonna ignore that. Where's I want the frequency readouts. Okay, so right now yeah, because the thing is, so I guess if I had a higher polling rate, I actually don't know what the boost spec for these CPUs is, so wait. Gonna try get it to boost. Are these supposed to do 4.4? Actually, I'll just Google it. I have no idea what a 3700X is supposed to do by spec. Oh yeah, it's supposed to do 4.4. Cool. So yeah, I guess I should update to the new drivers, or what, like the new chipset drivers. Come on. Like, the BIOS is completely on, like, auto settings, so it might also be that, but whatever. So, if we run a bit of single core, what does that do? Well, it does that. So, now our average voltage is about 1.47 volts. We're also pushing about 40 watts of CPU power consumption, which is why we're, you know, and this is a single core workload, right? Like, yeah, so if we go down to our temperatures, yeah, the temperature is going to be really high, because we're running 40 watts of CPU power consumption into one core. Also, that 200S average, that's 200 samples average, not 200 seconds average. Okay, if anybody was wondering, that's 200 samples. But I should have put 200 SA, because that way it would have been samples. Anyway, yeah, we're putting 40 watts into a single core on the CPU. Is gonna get hot. Right? Like, seriously, we're pushing, the chip is rated for 65 watts TDP. We're pushing 2/3 of the TDP into a single core, right? Like 1/8 of the normal surface area, like 1/8 of the normal volume of chip is basically being used, but at 40 watts. So yeah, the temperature under like single core loads, that's exactly what you would expect. Because the other thing to keep in mind is that the temperature readout from Ryzen CPUs is like the CPUs, I'm not sure what 3rd gen had, but 1st gen I think had like 64 temperature sensors or something stupid like that. And so when you check monitoring software, the CPU only reports like the highest sensor or something like that. So all of the monitoring software will basically just like, that's the hottest core that we're looking at right now. Like that 60 degrees, that's on the hottest core in the chip. That's not the whole chip. The whole chip's not at 60. There's just one part of the chip that's at 60, and we're getting the temperature of that. So yeah, however, this obviously has the like, you know, as I've been messing with this, I have noticed that I'm on the stock cooler right now, right? And I have noticed that the fan for the stock cooler just ramps up and down every time hardware info starts doing like CPU, does its pulling cycle. And yeah, I can see how that's really annoying. Like, I can totally see how that's really annoying, because basically what you're running into is that the fan just ramps up as soon as a single core gets hot. And it's not really going to do anything about the temperature, because the thermal limitation here is not the cooler, but the actual getting 40 watts of heat out of 1/8 of a chiplet is really hard. Is basically what we're running up against, right? Also, it's worth noting that pack. Oh no, it's going to be including the memory power consumption. So yeah, that's actually probably correct. Or I think it's probably including the memory power. Wait. Because I'm measuring the 8-pin. Like, the CPU power consumption reading is from the 8-pin. So, there's 40 No, we're at stock memory settings. There's no way it's pulling 60 watts. Yeah, no. Yeah, the power reading is not correct, so we can just ignore that. It's always fun to find out if the if the sensors on the motherboard, if some motherboards have accurate readings, some don't. This one doesn't. So yeah, anyway, if we just let it sit at idle right now, every time, every single one of these spikes, I can hear the fan ramp up. And it makes perfect sense, because basically when we get that spike, unfortunately, technically the power monitoring thing I've built is probably fast enough to catch those spikes, but it's not like I've not implemented the functionality to display them properly. Like, the idea was that the peak reading would show that, but that peak reading is an all-time peak, not like recent peak. So yeah, that's not working. Or at least, well, it's not doing what I'd want it to do to show, show this off. But anyway, if we run all core, what happens then? So we run all core, we start pushing about 70-ish watts into the 75 watts into the VRM, which makes sense, right? 75 watts into the VRM, 65 watts out. The power reading in the software is just completely bloody wrong again. I don't know where, there is no way there's 100. Actually, wait, what voltage were we at? Damn it, run it again. So average volt, yeah. And you can actually, if we zoom in on that. Oops. Oh no, that's 100 milliseconds. Let's go to 20. We boost algorithm. But I'm gonna shift it back out, and yeah, so you can see that after the load starts, it settles at a lower average voltage. So we're sitting at 1.13 volts. So no, there's no way it's pulling 100 amps, because at 1.13 volts, that would be 113 watts, and that's not going into the VRM, and there's no other voltage regulator connected to, the only other way power is getting into the CPU is from the VDDR rail, and I've checked that rail while, running Prime 95. It can't, with the current memory settings, it can't be supplying more than, 20 watts. Actually, even if we were running memtest, it wouldn't be supplying more than 20 watts. So, anyway, yeah, so software readings are as terrible as always. I basically, power monitoring in software for 90% of motherboards, I just completely ignore it. Unless it's a motherboard where I've checked that it's accurate, because on a lot of motherboards, it reports values that are just in violation of the laws of physics. So anyway, so that was a little bit of Cinebench. Let's start up something a bit heavier. Oh, Prime 95. So we run single core Prime 95. We actually get less voltage than single core everything else. So you can see that now we're running 1.44 volts. And also our temperature is just stupid high, right? I think this is the highest temperature we've measured so far. Yeah, right now 71.3 degrees Celsius. And again, this is because we're shoving now 45 watts, or no, 46 watts into 1/8 of the entire CPU chiplet, the entire core cluster chiplet. We're shoving we're shoving at this point, well, more than 2/3 of the TDP into 1/8 of that, right? So it's going to get really freaking hot. And it's really just like, it's not actually producing that much heat, right? Like it's producing somewhere around 46 watts of heat. But because it's so concentrated into such a small area, it translates into a stupid high temperature because it's so hard to get the heat out of the core. And our average voltage is, oh, and it's dropping as, I guess, it gets heavier. So, yeah. I'd assume as the temperature keeps rising, it would actually get lower and lower. So, yeah, the really high temperature for single core makes perfect sense because, again, that's going to be the sensor that's sitting inside that core is basically registering that core is stupid hot, which makes sense because we're shoving, basically the TDP of the chip into that core. So let's try something like I've actually not gone through all the different configurations of Prime 95 we can do, but I think we should go 2 threads, 4 threads, 6 threads, 8 threads, 12 threads, 16 threads, right? That makes sense. So let's do small FFTs now, 2 cores, and see what that does. And that's even hotter for reasons that can be clearly visible, that are clearly visible to anybody with eyes right now, because we're pushing basically the entire TDP of the CPU into 2 cores. So yeah, now we basically have a compounded issue of like, A, the CPU is actually pulling a lot of power, relatively speaking. B, all of that power that's going into the CPU is concentrated into 1/4 of the die, right? So yeah, it's going to be hot. Average voltage right now is holding around 1.39 volts, 81.3 degrees Celsius. Like, this is the side effect of having really aggressive boost algorithms. Like, you're going to end up, like, if Intel could do this, they'd be shipping 9900Ks at 5.3, 5.4 gigahertz boost. It would also not be it would be an equally unpleasant experience to use those CPUs. But yeah, I mean, considering how much power we're freaking pulling, right? It makes perfect sense that we're seeing that kind of temperature because that power is going into literally 2 cores, right? If we bring up Task Manager, and how do you do the change graph to logical processors? There. Yeah, like it's literally just mashing 2 cores with power right now. So those 2 cores are absolutely roasting and the rest of the chip isn't doing much of anything. So let's stop that. Torture test, small FFTs, 4 cores. Bam! So voltage has dropped again, but our power consumption is now... Oh, look, we've actually reached the TDP of the CPU at this point, because obviously we have to factor in voltage regulator losses, so 65 watt CPU, if you're pushing 65 watts into the voltage regulator, not actually 60 watts out, right? So anyway, now we're getting actually lower temperatures, because yes, we are pulling... 10 watts more power, but that power is now spread across twice as much surface area. So the thermal density is actually lower. So the highest, it's spread over more surface area inside the chip. It's actually easier to cool at this point, even though it's pulling more power. And our average voltage is about 1.29 volts. So yeah, that's like the thing is, this is AVX Prime 95. If we run non-AVX, it should be a bit lighter. So we can do that afterwards as well. And we should see higher voltages on non-AVX workloads. Anyway, let's try... let's do 6, right? I want to know what happens when you run 6 cores. There's our 6 cores. And now it's looking kind of like a Cinebench run. It's pulling, it's actually cooler again because we're pushing still the same amount of power, but now it's spread across even more surface area, right? So the temperature just keeps dropping. Because it's a hotspot thing. It's not actually like how much power you're pulling. It's literally just like, well, where's the power going? Right? It's like, so, yeah. That's why the temperatures end up being so ridiculously high on low loads. Is just like, because you're shoving all of that power into the small, like a very small part of the chip. So, yeah, there's not really, I can't really think of a way that AMD could fix that. Like, really, all they could try to do is push a, well, no, like, this is just how the chip's going to behave. Like, literally, this is just how it's going to behave, because if you want an algorithm where you're going to be capable of, because the problem is the chips don't really scale with voltage, which is why for like the 4.3 gigahertz or 4. Like we've not seen this chip do 4.4. I don't really care that much about that part, but since the chips don't scale that much with voltage, to get the high boost clock, AMD needs a lot of voltage, which basically translates into a lot of power consumption being shoved into a very small area. And the only way, like basically the only way I can think of them rectifying like the low load temperatures is like you just scale back the boost. Because if you want to, or that like, yeah, scale back the boost. Because the thing is, I don't think they, like the other option would be like some kind of undervolting, but AMD's not going to ship out, like they're not going to ship out a BIOS update that literally like lowers voltage on all CPUs by 50 millivolts because that's a reliability hazard, right? Like they have these chips validated to do those kinds of frequencies at those kinds of voltages. And so if you suddenly knock the voltage down by 50 millivolts, there's a good chance that the chip will start blue screening at random when you're running 2-core workloads or 1-core workloads. And that's just, no, like that's not really that's not a good solution to the high temperatures, right? Anyway, so if we now run small FFTs, we did 6, so let's do 8. And voltage keeps dropping, power consumption is lower. Oh wait, Prime 95 does load cycle a bit, so we'll give it a bit of time to warm up. But at this point, we're seeing actually very reasonable temperatures because, you know, all of the power that we are pulling is actually distributed across basically the entire chip, right? Like that's the thing. It's just like, if we look at our performance monitoring, the power draw is distributed across, you know, all 8 of our cores, so the chip's not going to get that hot. And at this point, I think we're probably just hitting the TDP of the chip. So if we go up to, I mean, we're actually hitting the power limit of the chip, not TDP, because, you know, TDP is a questionable rating these days. So let's just skip 12 threads. Let's just go straight to 16. So here we have 16 threads, and power consumption has dropped yet again. So actually our temperatures are very reasonable right now. Yeah, it turns out that, you know, if you're shoving, like, it's literally just down to how much power they're putting into one core. And it's just like, well, if you want high single core boost on a process that doesn't scale with voltage, there's not much of a choice, right? Like we're doing now what we're doing 0.9 volts. Like we're running full load at like idle voltage right now. So that's kind of like, you know, great. Though it is worth noting that, you know, I might not have the power monitoring thing configured like calibrated properly, but I don't think I've actually done like a proper validation of how accurate it is, but anyway, so, you know, margin of error on there exists, but the numbers seem reasonable. So also the peak reading is going to be affected like by transients and stuff, because that thing is actually set to update several thousand times a second. So it's fast, just not like, you know, it's just, it needs a bit of work. Like, the funny thing is, it's one of those projects I've been working on for a while. Well, not working on for a while. That's the issue, is just like, I built it. I was like, oh, this is neat. And it worked well enough for me to just use it every so often. And I've just not bothered to improve it ever since then, even though it has a lot of really obvious flaws. That's like, I wish it could do a graph, right? Like, ideally, I'd wanted to actually be able to do a live graph of power consumption and that kind of thing. Or at least spew out just, well, actually saving the values to a text file and then converting them into a graph is already possible. But, yeah, like, it could get a lot fancier than it currently is. Anyway, what did I want to test? Actually, no, let's try non-AVX prime. Right, because that should give us even higher voltage, because for AVX there's a bit of a voltage restriction. Man, the polling cycle from hardware info is infuriating. I can just hear the fan go woo, woo, woo. Shut up! Okay, let's go single-threaded. Ah, yeah, we are getting a bit more voltage, right? We're getting about 1.46, yeah. Because it's non-AVX, so we get a little bit more voltage. Temperatures are still stupid high, as you'd expect, because the voltage, like, yes, the actual current draw is lower, the actual voltage is higher, so your overall power consumption is higher. So anyway, let's stop that because the fan's ramping up to silly. Well, it's actually not ramped up that hard, but now if we run, 2 cores, it's probably like this should actually get even worse for temperature. We'll see. Yeah, so now we're doing like single core AVX voltages, but on 2 cores, and oh, but we're not pulling as much power. So yeah, AVX is a lot worse. So 2 cores of AVX instructions and chip goes through hell basically. Wait, are we running 2 or 3 cores? How many cores are loaded up right now? 1, 2. No, just 2. Cool. Yeah. So, and then for just to quickly do a comparison, we're going to go and run Prime 95 version 29, 2 cores, and we should see much higher temperatures. Test, torture, small FFTs, 2. Yep. Because it's pulling like 20 watts more. Isn't it? Yeah, it's like 10 or 20 watts more power shoved into the same amount of surface area. Ridiculous temperatures is the end result of that. So, yeah, I mean, I don't know. This to me looks like what you would expect to see based on how the algorithm is supposed to work. The fact that this is absolutely infuriating to the end user because your fan ramps up anytime any software does anything, even remotely heavy, is just like, yeah, I'm not sure how you deal with that. Didn't 9900Ks have a similar issue to this? I think they did. Can't remember. I don't pay that much attention to like, power management bugs because it's just like I turn that shit on, like I turn that stuff off. So just like, oh yeah, it doesn't idle properly. Oh, I couldn't care less. But yeah, this is basically like, yeah, this is how like expected behavior as far as I'm concerned. Right? Like you have 2 choices. You either run less like because the thing is it's just like from the CPU's perspective, it's really hard to know if you're running like, it's like it's really hard to like okay, so maybe you can do something like implement an AVX instruction offset, right? Like what Intel has, but the thing is, it's just like, well, are these important AVX instructions or are they not important AVX instructions? Or, is this set of instructions, is that somebody like opening a browser or is that somebody trying to play a game? And that's kind of, and apparently the new chipset drivers are tuned to try do that better, but I obviously don't have them installed for this. But yeah, the only way I could see this work is if you make the boost system like slower essentially where actually no, that actually would be a solution, right? Just have it like, because the annoying thing is that it ramps up like every time anything minor happens, so maybe just delay the ramping, right? And then delay the off ramp as well, because the biggest concern I'd have with any kind of like relaxed power management is like it would forget to boost inside a game, right? That's always fun with like GPUs that tend to do that, is just at least in my experience. It's always been, for me, the biggest problems have been power management on GPUs where it's just like for some reason the GPU has decided that my favorite choice of game is not game enough to boost. And then it's like, well, now it's running like a slideshow. Thank you, power management. That's exactly what I needed. But yeah, with the CPU, I guess all they can, like, they can basically go like, hey, if the workload lasts longer than X number of milliseconds, do boost. And then if the workload has stopped for more than, I don't know, like 100 milliseconds, right? Like, because, yeah, 100 milliseconds. This is a desktop processor. It's not a laptop, right? So, oh my God, can you imagine this kind of fan management policy in a laptop? Oh man, that's oh God. That would be really bad. That would be infuriating. Like, well, I guess depends on how whiny your laptop is. Well, yeah. So that's how Boost behaves if you don't have the chipset drivers installed. I'm not sure if I'll do a test of how the chipset drivers like the new chipset drivers behave because I really can't be bothered. But yeah, I did want to show how the boost system works, and also the high voltages. That's literally like the CPU basically has a set of like this voltage at this amount of current under these operating conditions is or is not safe. And the thing is just like with CPUs, you have different sort of things that cause degradation, right? So you have electromigration, which is mostly a current-driven thing. So basically, more current, more electromigration. How you get that current doesn't really matter because you get more current draw from higher frequency, from higher voltage, from higher temperatures, from different loading, right? So more current, more electromigration. So AMD basically goes like, well, we're not running a lot of current, so we can run really high, like on a single core workload, they might be like, okay, well, we know that the actual metal layers of the core itself, they don't degrade under like 1.4 volts. The transistors themselves don't degrade at 1.4 volts or 1.5 volts or whatever. It's like you'd have to ask TSMC or AMD to go like, hey, when do these transistors die? And then it also depends on how you actually have to power them. So like basically it's complicated. And unless AMD here's my belief, okay? AMD would not release a CPU that has a power management policy that'll kill the chip in less than a year. In less than the warranty period of the CPU. So, what warranty does AMD offer on these? Okay, well I can't find it right now, but wait, spec? No, I've literally just looked at that. Cool, whatever. But yeah, I would just make the assumption that AMD is not gonna implement a boost algorithm that'll degrade the CPU in less than the warranty period, because then they'd have to deal with a lot of RMAs. And they also probably wouldn't release a CPU that degrades, like, because they also have system integrators as, like, customers, and the system integrators would probably not be very pleased if they were given a bunch of CPUs where it's just like, hey, you can't offer a warranty longer than, like, 2 years or something for it, because the chip's going to die after that time period. So yeah, it's annoying that it has the side effect of the really high temperatures. I mean, yeah, that's annoying, but the actual voltage itself is just like, it like if you wanted boost, there's your boost, right? You can't have boost and not have power consumption. Like that doesn't work, because you need enough voltage to run the frequency. And yeah, and right now, ultimately, right now, yeah, it's spiking all the way up to like 5-ish volts. But actually, if we set the trigger up, can catch it. Bam. Zoom in. So, because I wanted the voltage level here. No, wait, I should stop it. There we go. Because I wanted to look at how high this voltage is. So it's spiking up to like 1.5 volts. So, yeah. Anyway, if we go there. Nope. Auto run. Zoom back out. So, also I should just turn the trigger off there. Yeah, I mean, it's behaving about as badly as you'd expect it to, considering what the algorithm is supposed to work with. So yeah, that's it for the video. Good luck AMD with solving this, because I guess, yeah, the easiest solution would be to just relax the rate at which the CPU boosts. But I mean, what's the main concern? Because the main concern is if your CPU is randomly stuck at 2.2 gigahertz, will you actually notice the loss in performance, right? Because if they slow down how quickly the boost kicks in or kicks off. Oh, it did manage to do 4.35 gigahertz somewhere along the way. Cool. Can we go higher? Okay, no. But still, it's just that's kind of the main concern, is if you relax it too much, it might get stuck on, you might be in the middle of a game and it decides to randomly go to 2.2 gigahertz. And in its current state, it's obviously kind of a little too aggressive, because it's actually really annoying. with how it just boosts up anytime like hardware info does some polling, it boosts. I assume if you open something like, actually, let's see what it does with like the 3D Mark menu. I don't think I have GPU drivers installed on this. I'll be very surprised if we have GPU driver. Oh, yeah, see, we don't have GPU. Yeah, see, the 3D Mark menu, because if I'm not mistaken, that thing is written in Java, and it's awful. Oh, yeah, it's really pissed off the CPU, hasn't it? Yeah, so... Yeah, so I can imagine if you have any application that's, like, remotely, like, this isn't heavy. It's running on 30 watts, but basically, if it runs on, like, a core or two, and it doesn't let the CPU idle, yeah, I can see how that can be a problem. But that's the thing is, like, AMD can't, like, I don't think they can go and, like, teach the CPU, hey, this is 3D Mark menu. You shouldn't boost on the 3D Mark menu. You should boost once 3D Mark is actually freaking running, though, right? Because then it's like, oh, you're setting power profiles per process. And, like, as cool as that would be if that actually worked, I don't think, like, it's, to me, it sounds like a whole lot of, like, you would basically be, you know, adding profiles per application. And that sounds just insane to do. Also, I guess if we just open up GPU-Z and GPU-Z's running, so we obviously don't have drivers, so GPU-Z. GPU-Z is actually pretty good about idling. That's impressive. So what else can we open up that I have on here? I don't really have much. Ooh, we have memtest. Let's test 6 gigs. Oh yeah, that doesn't make the CPU very... Oh. Is it not running? Oh, there we go. Now it's running. Yeah, so now we have memtest running. Yay! And that's obviously just got the CPU all hot and bothered as well, of course, because... Look, like, I think... it's like 6 threads that need to run, so the CPU is like, hey, we need to boost. And the thing is, I guess under memtest you would actually want to boost, right? Like, because you don't want your memory stress test to last forever, and the other issue is if your memory stress test isn't under full boost, then your memory controller is probably running at a lower operating temperature, and then for your... You know, then it's like, oh, but what if we run something hot and heavy and then your memory controller gets warm and then your system crashes because your memory controller warmed up. So, yeah, what else do I have here? Oh, I guess we could look at some screenshots. What's this? Oh, we have a random screenshot. Okay, so now it's idling again, but if I just go... no? Can't go through them? Windows, you stupid. Alright. Oh, does scrolling through folders? Oh, yeah, scrolling through folders gets it really triggered. Okay, so... Yeah, it's a little bit overly sensitive, but the downside is, like, obviously if you make it too insensitive, it's just not going to boost when you actually need it. So that's kind of the main issue, is just, like, how do you balance the user experience of having a fast CPU with having a CPU that doesn't boost at the first, like, hint of a workload, right? Like, doing that. So, yeah, because apparently that constitutes a heavy enough workload to activate boost. And admittedly, I don't have GPU drivers, so maybe that would get, like, GPU accelerated out of the way or something, but still, it's just, like, yeah, that's the boost behavior on Ryzen 3rd Gen. Like, the voltages themselves, not really a concern. The temperatures that they cause, also not technically a concern, but the fan management as a result is, I agree, very annoying. I guess you can set, like, some kind... Well, I don't know. I've not messed with motherboard fan control software that much, but if you had fan control software that just slows down the fan ramps, like, a lot... well, actually, no, because potentially then under full load, you'd be screwed. Yeah, no, they just need to slow the damn thing down. Like, the algorithm just needs to not freak out when somebody does that. So... Yeah, anyway, that's it for the video. Hopefully this was somewhat, educational, I guess? I don't really feel like it's very educational, but, you know, hopefully this gave you some idea of why Ryzen behaves the way it does behave. And yes, this is intended behavior, and I do agree the intended behavior is actually kind of stupid, which is why, you know, AMD's working on fixing it. But yeah, like it's not easy to get this right as far as I'm concerned, because obviously, like, there's two extremes, right? You either boost all the time and your power savings suck, or you don't boost enough and then you have like stuttering in games and stuff. So yeah, and I think at this point I'm just repeating myself over and over. So I guess thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, I do have a Patreon where you can support me directly. There's a link to that down in the description below. And then I also have Teespring if you'd like to pick up any sort of actually hardcore overclocking merch, like stickers, posters, hoodies, socks. And there's a link to that down in the description below as well. And yeah, is that everything? That's the full outro, right? Like, I haven't forgotten anything. Yeah, I think that's the whole outro. So where's the mouse? There's the mouse. So yeah, thanks for watching, and goodbye.